Hello there. Today this video is on the properties of tangents, a part of Target 3, identifying and applying properties of segments that intersect circles. Let's get started. In example 1, we need to tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent to circle C. So let's start with BC. Well, as you can see, I highlighted BC in orange. BC is the distance from the center of the circle C to a point on the edge of the circle B. So BC is called a radius. The next line is line EA. So line EA is a line that extends forever in both directions that cuts through the circle. It doesn't necessarily intersect on the inside or on the outside, but what we do notice is that this line intersects the circle at two different points, and what we call this line is a secant. And finally, we have ray DE. So ray DE is a ray that intersects the circle at one point. So I put a point at B there. A line outside the circle that intersects it at one point touching the circle is called a tangent. And the point where the tangent line intersects the circle right there is called the point of tangency. So let's draw in some common tangents. Tell how many common tangents the circles have and draw them. So the first common tangent, remember, tangents are lines that intersect the circles at one point on the edge of the circle. So this is our first tangent. Now you can see that this tangent intersects both circles at only one point. So that makes this line a common tangent. We have another common tangent on the other side, and finally one more common tangent in the middle where it intersects the two circles at the same point. So total in these two circles we have 3 common tangents. In the second circle we have a tangent on the right hand side that intersects both circles at 2 points, a tangent on the left hand side, but this time we don't have a tangent in the middle, because if we did, then it would intersect at 2 points, which would not make that a tangent anymore. It needs to only intersect at 1 point per circle. So this has 2 common tangents. And finally, in the last picture, both circles touch a tangent line on the right hand side. They intersect at 1 point for each circle, so we have 1 common tangent. Intersection of a tangent and radius. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its end point. So you can see that we have a tangent line on the outside, and that intersects the radius, OP, on the inside of the circle, and where they intersect, they form a right angle. So we can say that the line MP is tangent because it intersects the circle at a right angle. In example 3, we want to verify if ST is tangent to the circle. In this diagram, RS is the radius, is ST the tangent. So we basically, what we want to figure out is if where the radius intersects the supposed tangent, is that perpendicular? In order for that to be perpendicular, which means that if ST is tangent, then that means that triangle RST must be a right triangle, because right triangles, that would make angle S that right angle. So we need to verify if, using the Pythagorean converse, if c squared is actually equal to a squared plus b squared. So let's start with c squared. Well, across from our supposed right angle, angle S is 26, so that's my hypotenuse squared, and you can choose either of the other two sides for a squared and b squared. So we want to see if that is equal to 10 squared plus 24 squared. So let's do some computing. 26 squared is 676. Let's see if that is equal to 100 plus 576. Well, 676 is equal to 676. Since those are equal, then we can say that angle S is a right angle, which makes ST tangent to circle R.